Myself, Proparanjay, working as an assistant professor in ECE department at SNS College of Technology. In this lecture video, I am going to discuss about the topic is review of signals and systems from Unit 1, that is the discrete Fourier transform. From the subject name is digital signal processing. Yeah, let us discuss. Review of signals and system is fundamental in understanding a wide range of field in engineering and science. It lays the groundwork for analyzing, designing, and implementing systems that process or transmit information. Also, why this review is important, which is for fundamental understanding of signal processing. So only this review is much needed for this purpose only. Okay. Okay, first of all, we have to know about the what is signal. Signal is nothing but the it is the function of one or more independent variable which contain some information, which means either radio signal or TV signal, that is electrical signal or non-electrical signal. All are the signal is a function of time, that is f of t, and which is classified into two types. First one is analog and digital signal. Analog signal, a signal that is defined every instance of time, is known as analog signal, that is continuous time signal. Both amplitude and time period is in continuous in manner, whereas digital signal that are discrete in time and quantized in amplitude is called digital signal. Okay, mainly the signal classified two types, which is continuous time signal or analog signal and discrete time signal. In continuous time signal, both amplitude and time period are in continuous in manner. In discrete time signal, amplitude is in continuous in manner and time period is in discrete in manner. It can be further classified into four types, that is periodic, aperiodic signal, even and odd signal, that is symmetric, asymmetric signal, energy and power signal, deterministic and random signal. And what is continuous time signal? That is defined for every instant of time, is known as continuous time signal. Continuous time signal are continuous in amplitude and continuous in time. It is denoted by x of t. Whereas discrete time signal, continuous in amplitude and discrete in time. It is also obtained by sampling a continuous time signal. It is denoted by x of n, x of small n. The small n represent the number of samples. This is the graphical representation of continuous and discrete time signal. And next one is which is further classified into four types, that is periodic and aperiodic signal, energy and power signal, symmetric, asymmetric signal, deterministic and random signal. First one, periodic signal. What is periodic signal? The signal that repeat its pattern over time at regular interval as known as the period. In other words, after a certain amount of time, the signal will repeat exactly as it did before. A discrete periodic x of n is one that repeats its pattern over time with a fixed period of capital N. Mathematically, this periodic signal can be represented as x of small n equal to x of small n plus capital N. The capital N is the period of the signal. Okay. And aperiodic signal, the signal does not repeat the certain pattern, which is called the aperiodic signal. and periodic signal. You can see the periodic signal and aperiodic signal in the graphical representation, in the form of graphical representation. Next one is symmetric signal, asymmetric signal, even part of the signal and odd part of the signal. A signal is said to be even signal if the inversion of the time axis does not change the amplitude. For better example is cosine signal, that is x even of n equal to x of n plus x of minus n by divided by 2. And whereas odd signal is nothing but the if the inversion of time axis also inverse the amplitude of the signal. The best example is sine wave, and mathematically represented as x of n minus x of minus n divided by 2. That is the odd part of the signal. By using this formula, we can find the odd part of the signal. And next one is energy signal. If we can say energy signal means the condition is energy value should be infinite and power value should be equal to 0, whereas power signal in the sense energy value is infinite and power value should be infinite. And first is energy formula for the energy signal, and second one the power formula for the power signal. Deterministic and random signal, a signal which can completely represented by any mathematical equation, for example sinusoidal signal. Random signal, a signal which cannot completely represented by any mathematical signal, which is best example is noise signal for random signal. And some of the elementary of the signal, that is unit signal, impulse signal, and ramp signal. Unit signal is defined as u of n equal to 1 for n greater than or equal to 0 and 0 for n less than 0. You can represent, you can see here graphical representation of u of n. And next one is del of n. Del of n means impulse signal. Del of n equal to 1 for n equal to 0, 0 for n not equal to 0, r of n equal to n for n greater than or equal to 0 and 0 for n less than 0. Next one is system. A system is a set of element or functional block that are connected together to produce the output with respect to the input signal. Here you can see the best example of the system. Whether the system input is analog means analog output, we can get the analog output. In case discrete means we can get the discrete output. This is the sum of the systems. Continuous time system, discrete time system. Whereas continuous time system, it operates on a continuous time signal, which is analog signal, produces another analog signal, that means output response. And whereas discrete time signal, it operates on a discrete time signal and produces another discrete time signal. And some of the application area, that is communication, audio speech processing, image video processing, biomedical engineering, these are the application area. This is the assessment for this video lecture. You can note and comment me the answer. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.